This is Katie Bowman's AP problem number 8. So let's start by reading the equation and the information it gives us. So it gives us an equation at the top, NH3 plus H2O yields NH4 plus OH minus. And it says, in aqueous solution, ammonia reacts as represented above. In 0.018 molar NH3 at 25 degrees Celsius, the hydroxide ion concentration is 5.6 times 10 to the negative 4. In answering the following, assume that temperature is constant at 25 degrees Celsius and that volumes are additive. So let's start with part A. Part A asks us to write the equilibrium constant expression for the reaction represented above. So if you look right here for part A, we're finding a base, so it's going to be Kb, and you're going to use this equation, and you're going to put products over reactants, but we're going to exclude H2O because it's a liquid. So our final one will be concentration NH4 plus, concentration OH minus over NH3. Alright, so then part B asks to determine the pH of 0.018 molar of NH3. So we're going to set it up like an ice box. So we're going to use the equation NH3 yields NH4 plus OH. I just excluded H2O because you're not going to have any information for that anyways, but it's still there. So you start with the initial concentration of NH3, which is 0.018, which is what they gave you at the beginning, and then the products have 0 because the reaction hasn't happened yet, negative X because you're losing it, and then positive X because they're going to be gaining because the reaction is shifting over. And so then you put it together, you get negative 0.018 minus X, and then X and X. And so what you're going to do is you're going to take the Kb for the equation, or for NH3, which is 1.8 times 10 to the negative 5, and you're going to plug in these into the equilibrium expression above. So it's going to be x squared over 0.0180 minus x, which I crossed out because the equilibrium expression is so small, it's not going to make a difference. So you just cross the negative x out, and then you want to get rid of the fraction. So you take this number and you're going to multiply it over, and then when you multiply, you get 3.24 times 10 to the negative 7 equals x squared. You want to get rid of the squared, so you just do a square root to cancel it out. You're going to get 5.70 times 10 to the negative 4 equals x. That's your concentration of OH minus, but it's asking us to determine the pH. So when you have OH, you need to find POH first, so you're going to do negative log of this, so I just put an arrow down, so you're going to negative log this number, that's going to be the POH, and then to get to pH, you're going to subtract, so you're going to do 14, you're going to subtract what you would get from the negative log, which was 3.24, so your pH is 10.76, so it's basic. Then part C asks to determine the value of the base ionization constant Kb of NH3. So you are going to use the part A that you have. You're going to use this constant equation, and you're going to use the OH minus concentration that it gave you. And NH4 and OH minus are going to have the same concentration, so you can just square that number on top, and then they also gave you the 0.0180, so you're going to put that on the bottom, and you just do the math for that. And you're going to get 1.74 times 10 to the negative 5, and that's it. That one's not too bad. Then part D, determine the percent ionization of NH3 in 0.018 molar NH3. So for the percent ionization, you're going to do the concentration of the one being ionized over the initial concentration. So you're going to do that, and then you're going to times it by 100 to get a percent. So you're going to use the number that we found when we were doing our ice box, which was 5.6 times 10 to the negative 4, but you're not going to square it because you're just doing it for OH. You're going to put it over the initial concentration that they gave us, which was 0.018 0.18, and then you'll times it by 100 to get a percent, so you'll get 3.11% ionized, and that's it. Okay, bye.